Hello, and today we're going to be learning about graphing. Now, the aim is how our graphs are drawn, and the objective by the end of the lesson. Now, the lesson is not just this podcast, of course. Includes tomorrow's lesson, where you will be able to graph data from a data table. And I'm going to be modeling how to do that, and in class tomorrow, you actually will be doing that. And this is important in science for several things. In science, that's a few things. One is that scientists use graphs because it allows us to really look at the data visually, and we can see patterns that we wouldn't be able to see just by looking at a string of numbers in a data table, and there can be lots and lots of numbers in that data table. And another reason why we need to do this is because it's so common in science, because it's so important. There is a graph on every single Regents exam. So there will be a graph coming up on your next unit exam. And as I said, I can guarantee you that there will be a graph of some kind on the Regents exam that you'll be taking in June. Okay, so let's move on to the Regents question that we're going to be solving. And here's the question. I'll just read it for you. 3 students each added equal volumes of pond water to 4 beakers and placed each beaker in a different water bath. Each student maintained the water baths at temperatures shown in the data table. The students then added an equal number of water fleas to each of the 4 beakers. By the way, water fleas are sort of like microscopic shrimp. After 1 hour, the students used microscopes to determine the average heart rate of the water fleas. The procedure was repeated for a total of 3 trials at each temperature. The results of the investigation are summarized in the data table. And here's the data table. As you can tell, we have 2 different variables. We have one variable is water temperature, and the other variable is average water flea heart rate. Even though it's microscopic, it's an animal, it has a heart. And we are going to have to graph all of these things. Now, let me just get out the eraser. Now, we have to see which goes on the x-axis and which goes on the y-axis. 2 ways you can look at this. One is it's the way you generally see it on the Regents exams, from what I've seen, is it's alphabetical. We have x comes before y. We also need to be able to figure out which is the independent variable and which is the dependent variable. Because the independent variable is what goes on the x-axis, and the dependent variable is what goes on the y-axis. And generally you have to know for other Regents questions too. And way to figure out which is which, it sort of tells you in the word. The independent variable, its value is independent. The dependent variable's value depends on the independent variable. So if you look at water temperature, and then you look at average water flea heart rate, which depends on the other? Does the water flea's heart rate, if the water flea heart rate starts beating faster and faster, will that make the water temperature go up? Or will it make it go down? Or is it the other way around? If you increase the water temperature, will that make the average water flea heart rate go up, or will it make it go down? And to me at least, it seems fairly obvious that changing the water will change the average water flea heart rate. So here, by the way, is what I was just saying before. And this should definitely go into your notes. You do need to take notes watching these podcasts. The dependent variable depends on the independent variable. And since the water temperature will change the average water flea heart rate, at least that's what we're trying to see if it does. The water temperature is the independent variable, and the average water-free heart rate is the dependent variable. Now we're going to have to graph this. So let's, first I'm going to move this, get a pen out. And let's go to the graph. Now on this graph, it actually tells you which goes where. And that can sort of help you also in terms of dependent or independent. I went over what I just went over because it doesn't always ask you where you have the graph. And you're going to have to put your graph on here. Now if you notice that the numbers aren't there, the first thing you have to do is you have to put the numbers in, you have to do a scale. Now what I'm going to do, let me go back here, is I'm going to first put these numbers in. I'm going to put them in wrong just to show you the problem with it. And I'm going to do it the way I've seen a lot of students do it in the past, and they lose points for it because of that. So we'll start off here. We'll put in the line, and we'll write in over here 0. And then over here we'll put in a 5, and sorry that my handwriting using a mouse is not the best. And the next one is 15. And by the way, my writing that little line there is actually doing something correct. It should always put a little line there, that way I can tell which is which, where each one goes. So we got 15, and then after that is 25, and then oops, 25, and then 35. Yeah. And over here we have 25, and then down here goes 35. Okay, now there are a couple problems with doing it this way. One problem is, since this is the highest number that we have all of this wasted space here on this graph. And not that part. Get our eraser again. So we've got all this wasted space. The second problem is this. Now, if you did your graph like this, just having it end over here at 35, that would be okay so far as the exam is concerned. I would not take any points off for that. Problem with this is that by scrunching in everything in here, it will make it hard to actually use the graph. Sometimes you're on other questions after this, you have to use it, and if it's all scrunched in here, it's hard to actually see everything clearly. If you have it all spread out, it's much easier to see it. Second problem is a bigger problem, and that is this. You look over here, from here to here, it's basically 5 degrees Celsius. From here to here, it isn't 5 anymore, it's 10, and then 10, and then 10. You have to have a constant scale. You can go, and it's also got to fit on here. You can't have it going off on there. You can't, sometimes I see people that they will go further here, and they'll draw in their lines, sometimes not as straight as I'm doing here. And they put in their dots. You can't do that. You're going to lose points on the scale. You have to stay within the graph here. But it also has to be, and even more important, it's got to stay constant. If between these two lines here it's 5, it's got to stay 5 the whole way, or it's say 10 the whole way, or 1 the whole way, or 100 the whole way. I didn't have to start at 0. I could have started at 5 because our first over here starts as 5. But the important thing is that your whole graph has got to appear on the graph paper, and it's got to be constant going across here. If you don't have a constant here, try this. Try taking this over here and graphing it, where like you say you skip every couple lines. You put first one, you got 5 and then 40, and then you skip a couple lines, and then you got 15 and 119, and so on. What you end up with is you end up with a straight line. It's not going to tell you anything about your graph. Okay, so let's get rid of these things here. Get rid of that, get rid of that, get rid of that. All right. And I'm going to leave this 0 in here. I don't have to. I can start at 5. Now, actually, what I'm going to do right now, sorry. What I'm going to do right now is I'm going to do this part here for real. Now, let's see. How many do we have? First thing you want to do is say, okay, how many do we have going across here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's not enough to get to 35. So let's see, if we go by 5, you got to see 5, 10, 15, 20, 25, 30, 35. We get you up to here. We go by 2s. 2 should do it. So you got here 2, and then we've got here 4. Okay, so do it. 2, 4, 6, 8, 10, 12, 14, 16. Yeah, probably 4. Just not used to that. So it all fits, because 35 is right in the middle. Okay, now for the y-axis. Goes up to 280. And let's see, if we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250, 260, 260. Yep, by 10s is fine. So, we got here 10. And over here, we'll put here 20, 30, 40. Doing the same things as before, just focus at time and also put a little bit neater. 50. Okay, so first one, 5 and 40. Now the way they always try to do it is if you got more than one, they'll tell you what to put around. So you have 5 and 40, right? 5 and 40. So here's 5, here's 40. So we put a dot and a circle around the dot. They tell you to do this in the instructions, so if you just follow that, you do it. If you don't put in the circle, that's okay, unless you've got 2 lines of graphing, in which case it's really important to put it in, so I know which is which. Next is 15 and 119. So 15 is 15 is right here, and the other was 119. Yeah. Okay, so 119 is right about over here. Circle around there. And then we've got 25 and 205. 25 going up to 205 is right here. And the last one is 35 and 280. 35 is right here. And 280 is right there. And the last thing you do is you connect the dots. That's okay. You don't have to use a straight edge or anything like that. And this is what it looks like. What some people do, and this is why I put the 0 in here. What some people do, and I'm going to change the color of the pen. Some people do is they will draw. Whoops, there's that. What some people do is they will draw a line down to there. Don't ever do that, because there is no data point here. The only time you should draw a line down here to the origin is when you look on here. It would say over here 0 degrees Celsius gives you 0 beats per minute. And in fact, that would mean that the is dead at 0 degrees. That may not be true. It could be over here, like if you follow this line here, it's actually, at 0, it's probably right about over here. So it's wrong to put that there, and if you do that, then you will lose the points for drawing your, for basically for plotting your points. Now it's important to get it right because on the Regents exam, it frequently happens that if you get 1 point off, you don't get any credit. If you don't connect the lines, you don't get any credit. Now, if you mess up with the scale, what you drew here has to match what you've got here. Otherwise, it's going to be double jeopardy. Okay, now there are a couple questions on this, and these are the 2 questions. And the first one asks what an independent variable is, and for this we just go back over here and okay, what's on the x-axis? Water temperature. So that's a quick way to do it. Temperature of the water. State the relationship between between temperature and heart rate and water freeze. Okay, whenever you see, almost every Regents exam, they ask you the relationship between 2 variables. The answer I always want you to put down is as A goes up, B goes, and then you fill in the blank. It's either B goes up, or B goes down, or it stays the same, or there's no relation. Usually it's one goes up and the other goes down. So you look on here. Go to the graph here. So, as water temperature is increasing, in other words, as this value here gets higher and higher and higher, what is happening to the heart rate? Well, if you look on here, as this number goes up, so is this number. You got 6 and 40, and bring the 5 and 40. Bring the 5 over here up to 20. At 20, it looks like we're about 140. It's gone up. So what we would say over here is that as temperature increases, heart rate and water freeze increase. Okay, and this brings us to our closing questions, and these are the questions that I want you to ask. I want you to answer, and you're going to be handing this in tomorrow. And this is how like I've done before, this is how I see that you've actually seen this podcast and you've gotten the main things. And if you don't remember the answer, feel free to play the vodcast over. And of course, you can also use this back in June when you're studying for your Regents exams. Okay, so the first one here is why is data graphed? Second question, which variable goes on the x-axis? Third question, list 2 important characteristics of a good scale. Fourth question, when is the only time that you would draw your line graph to the origin, which is at 0, 0. So I'll just answer these questions, hand them in to me tomorrow, and I will see you in class tomorrow.